Good morning. I am out sick today, but I'm making this video from home because I love you. So we're going to start by just finishing up what we learned on Friday, which is simplifying rational expressions. And I have a little treat for you because our notes are going to be from the homework. So if you turn in your pink book to page 22, go to page 22. We're going to do these problems from your homework. 3A, 3B, 4A, and then number 5. Okay, you'll finish the rest of this page for homework later. All right, so let's take some notes on the side. Pull out a separate sheet of paper and follow along. This is kind of like a review from Friday. So rational expressions, the definition of a rational expression, what are we talking about? Well, it's a fraction that just has a polynomial in the numerator or the denominator. So these are all examples of rational expressions right here. We've got 1 over x, because we have an x in the denominator. That makes it a rational expression. We have x plus 2 over x minus 4, and even these kind of more intense looking ones have polynomials both in the numerator and the denominator, and that's fine. These are all rational expressions. There's something a little kind of awkward about these expressions, and we have to be very careful with them. Unlike a normal polynomial, like let's say y equals x plus 2, in which case I can plug in any value of x. I can plug in 0, because 0 plus 2 is 2. And I will get a valid y value. I could plug in negative 5. Negative 5 plus 2 is negative 3, and that's a normal number. I could plug in a decimal or a fraction, and I will get something, I'll get a real number. But when I'm dealing with rational expressions, there is one value, so I'm looking at this first rational expression right now. There's one value of x that I cannot plug in because it will give me an undefined, or it does not exist, or an error if I put it in my calculator. In this case, x cannot equal 0 because I can't divide by 0. If I were to plug in 0 for x, I will get 1 over 0, which is undefined. That does not exist. Okay, so you cannot divide by 0. Let's make a note. Cannot divide by 0. And since we have x's in our denominators, we have to watch out what we're plugging in. We need to make sure that that denominator never ever equals 0. So this leads us to the idea of excluded values. There are some values we just have to say, hey, plug in anything you want. Any value of x goes, right? They're all part of the domain. Domain are the values that x can take. But for this expression, I have to exclude 0. That's not part of my domain. For the second problem, so again, I need to figure out what value to exclude. I'm not worried about the numerator. My numerator can equal 0, right? Because 0 divided by monkey or any number is just 0. But if I have it the other way around, 0 in my denominator, that's a problem. So I'm not worried about my numerator. I'm going to just focus down here. What value of x will make the denominator equal to 0? Well, I can actually set it equal to 0. We can do the math and see. Solving for x. So if x equals 4, that makes this expression equal to 0, which is not allowed. So I'm going to exclude x equals 4. This is my excluded value. So again, let's look at it, what we just discovered. If I'm plugging in 4 into x, then I get 4 minus 4, which is 0 in my denominator, and that's not allowed. Okay, sad face, not allowed. In this problem, the value of x that makes my denominator equal to 0 is negative 3. And I can actually show that by setting it equal to 0 and solving. So I need to exclude that value. So what we're doing essentially to find our excluded values, because you will be asked about this, you have to state it. your excluded value, that's what x is not equal to. You're going to find it by setting the denominator equal to 0 and then solving for x. And then you're going to exclude that value. Let's do that over here for our third example. So what value of x will make our denominator equal 0? You can probably guess by looking at it that x cannot equal 2 because 3 times 2 is 6. 6 minus 6 is 0. But if you couldn't tell by looking at it, you can always follow our process down here below. Set the denominator equal to 0 and then solve for x. I'm going to get 3x equals 6. Divide by 3. I get x equals 2, and then I'm going to exclude that value. Okay, so simple enough so far. Let's look at our final problem over here on the right side. So in this case, there are two values of x that will make my denominator equal to 0. And if I show the work, I can use factoring to solve. Somebody recognize that this is the difference of squares. X minus 3x plus 3 equals 0. And so by setting each of these equal to 0, I find out x equals 3 and negative 3. These are the values of x that when I plug it in will make my denominator equal 0. So we will exclude those values. Okay, so that's our discussion on excluded values. I want you to be finding your excluded values first, every single time. Because next we're going to start simplifying these rational expressions or factoring and canceling them out. So now let's deal with number 3a. First, we're going to find our excluded values. So as discussed before, we'll set our denominator equal to 0. We're going to show the work. So this is a more involved problem. So to solve for n here, I'm going to have to factor. So factoring, let's see. We must always try greatest common factor first, if possible. We also have our magic x. We also have difference of squares, right? We have all of these different methods. In this case, I can do I can do greatest common factor because I can take out a 10. I can also pull out an n, and I'll be left with 3n plus 1. And now by setting each factor equal to 0, I get n equals 0 and n equals negative 1/3. These are my excluded values. Okay. Now coming back to the problem, the question for 3a actually says simplify. So the most common mistake people are going to make right here, right now, is they'll see a 30n squared, a 30n squared, and think, those cancel, nice. But that's incorrect. Remember, there are like invisible parentheses on my numerator and denominator, and we can't just cross things out by division, overriding our parentheses, because we know that parentheses take precedence, right? Parentheses come first before division. So we can only cancel things that are already pieces that multiply, right? We can only cancel factors. For example, if I had 30n and 30n, and then I had like a 5x and a 5 plus x, right? Now that my 30n is a factor, it's being multiplied, now I can cancel it out with that factor. And I would be left with 5x over 5 plus x. But these 5's won't cancel because the bottom is part of a group, right? 5 plus x. That guy stays together. So we have to keep that in mind, that we need to factor first as much as possible, then we'll cancel or simplify. Okay, so let's factor the numerator. We can pull out, using greatest common factor, we could pull out a 10 and an n. and we'll be left with 3n minus 5. So that'll give me my 30n squared minus 50n. Now let's do our denominator. Hey, we already factored our denominator. Remember we did that over here? For our excluded value? We don't need to recreate the process. We already know we can pull out the 10n, and we'll be left with 3n plus 1 from our previous work. Now we'll observe. Okay, I have this factor, which is a 10n. It's identical on the top and the bottom. So that simplifies. 10n over 10n leaves me with 1 over 1, or it disappears, basically. And I'm left with 3n minus 5 over 3n plus 1. Now, again, people will be tempted to cross out these 3n's here, but that's not allowed because they're not factors right now. They're just the plus and minus sign are prohibiting us from canceling them. And this is our final answer, our most simplified version, just 3n minus 5 over 3n plus 1. Okay, let's do 3b now. So as always, we're going to find our excluded values first. We'll do that by setting our denominator equaling to 0 and then solving. So I'm going to solve this again. I notice that I can pull out a 2 from each term. So we'll do that right away. And we can continue factoring because now I recognize a difference of squares here. So the 2 stays, but this becomes x minus 6, x plus 6. And finally, I get x equals positive 6 by setting that equal to 0, and x equals negative 6. These are my excluded values. Right? X cannot take these values. So this means that 6 and negative 6, they're not in the domain. The domain, remember, it means all the values that x can take. And we're saying x cannot take these values. So that means these are not part of our domain. Okay? X cannot take those values. So coming back, we're done with our excluded values. We've stated what we need to state. Now let's simplify this. As is, nothing is going to cancel because we always have to factor first. Okay, so in our numerator, we'll factor this using magic x. Two numbers that multiply to negative 42 but add up to negative 1. Those will be 7 and 6 with the 7 being negative. So I'm going to get x minus 7, x plus 6 all over. And hey, we just factored this. Remember, we pulled out the 2. We were left with x minus 6, x plus 6. You can redo the work, but if we're finding our excluded values first, you've already done the factoring. So we can just remember that. Now, we're going to simplify by canceling out our common factors on the top and bottom. So everything's going to cancel as a unit. This x plus 6 and this x plus 6 cancel each other out. And everything else remains. So this will be my final simplified version. Or if I want to distribute this 2 in, I can get x minus 7 over 2x minus 12. Both of these are correct because they cannot be simplified anymore. Okay, let's do 4a. So we're going to start by, let's label our excluded values as always. So we'll set the denominator equal to 0 and solve. So I want to solve for n. We'll add 6 to both sides. Divide by 3. I get n equals 2. That's my excluded value. N cannot equal 2. Because if I plug that in, I'll get 6 minus 6. I'll be dividing by 0, which we know is undefined. Is not does not exist. Okay, so we're done with our excluded values. Next, we'll simplify this. So up top I have a magic x, and we can, since there's a 2 out in front, I either have to use the long way, factoring by grouping, or we can use our magic x, but remember to divide by that 2. So I'm going to need two numbers that multiply to -12, but add up to -1. So 4 and 3, with my 4 being the negative. But I can't just go and write n minus 4 and plus 3, because remember, I have this coefficient out in front. So, recall from a couple of units ago, we're going to divide both of these numbers by the 2. Since this simplifies, I'll rewrite that as -2. Since 3 over 2 does not simplify, I put an x in the denominator. Or sorry, an n rather. So what I'm dealing with then is n minus 2. That's from this piece. And then 2n plus 3. And that's from this piece. Remember, read it bottom to top. 2n is the bottom, and then plus 3 up top. All over 3n minus 6. So I could write 3n minus 6, but I actually am looking for factoring opportunities. And in this case, I can factor out a 3. And I'll be left with n minus 2. And that works out nicely because I see an n minus 2 on top and n minus 2 on the bottom. We can cancel them out. We're left with 2n plus 3 all over 3. Do these 3's cancel? Heck no. Not allowed. This plus sign is prohibiting us from doing that. Plus, we've got invisible parentheses, and we cannot just cancel through our parentheses because parentheses come first before division. So this is our final answer. Another way we could write this, and I just want to show you multiple ways because it's important for testing and just to remind ourselves what we can really do with our math. We could split this up as 2n over 3 plus 3 over 3. And so I could rewrite it ultimately as, or actually, I would have to rewrite that as 2n over 3 plus 1. Or 2/3 n plus 1. These are the same thing. Okay, you might want to just leave it like this, or you can leave it like any of these. They're all equivalent. Okay, let's go to the last problem, number 5. It says calculate the expression with an excluded value of 7. So if I have an excluded value of 7, that means if I were to plug in 7 into the denominator, that I would get a 0 for my denominator. So here's what we can do. We can either plug in 7 everywhere, or we can actually find the excluded value for each. I'm going to go ahead and find the excluded value for each. So let's start with A. Our excluded value, we always set the denominator equal to 0 and then solve. So two numbers that will multiply to -14 and add to -5. 7 and 2, with the 7 being negative. So I get x minus 7, x plus 2 equals 0. So x equals 7 will make this equal to 0, and x equals -2. That means these are my excluded values. So x cannot equal 7. We have found our excluded value of 7. But let's look at B. Why wouldn't B be the answer? Well, if we plug in 7 for x, 7 plus 7 is 14, not 0. So we're allowed to divide by 14, that's fine. Our excluded value here is actually -7. Because if I set this equal to 0 and solve, I'll get x cannot equal -7. So if you're not paying attention, you might look at B and say, oh, that's the 7 in the denominator, yeah. And you might choose that without thinking too much about it, but you have to be careful. Okay. And then finally, let's look at C. For C, there is no x in the denominator at all, right? There's not an x down there. So no matter what I plug in for x, I can never make my denominator equal 0 because my denominator is always going to be 4. So for this one, we have no excluded values. We can plug in, our domain rather, is all real values, or all real numbers, because we can plug in anything for x, because it'll only go into the numerator, and I can have anything I would like in the numerator. Nothing's going to make my denominator equal to 0. Okay, so for your homework, part 1, I want you to finish pages 21 and 22 if you didn't finish it already. So homework, page 21 and 22, I just want you to do all the problems. Okay, since this is our second day on this lesson. All right, go have fun, and remember to check the class website for the full solutions. Thanks.